Welcome you all to session 3 of the chapter Motion in a Plane. In the last session, we were discussing about mathematical operations on vectors. We have learnt how to add the vectors, how to subtract a vector, how to multiply a vector with a scalar. Today's session will be how to multiply a vector with a vector, that is multiplication of vectors. Okay, that will be the session of today, that is multiplication of vectors. Multiplication of vectors. How to multiply the vectors. Multiplication of vectors. The product of two vectors is of two types. Okay, the product of two vectors is of two types. The first one is scalar product. The first one is scalar product and the second one is vector product. Scalar product is also called dot product. Vector product is also called cross product. Right? Okay. Multiplication of a vector with a vector, we have two results. One is scalar product and another one is vector product. Scalar product is also called dot product. Vector product is also called as cross product. And we will be learning these two in detail now here, right? So multiplication of vectors are of two types now here. One is scalar product and another one is vector product. Okay, let us begin with the first one, that is scalar product. Okay, first we shall understand what is the meaning of scalar product. Scalar product, or it is also called as dot product. Why it is called dot product? We will be understanding in the session here. What is a scalar product? If you multiply a vector with a vector and if the result is a scalar, then that product is called as scalar product. Right? If you multiply two vectors, the result is a scalar, then that product is called as a scalar product. Right? Okay, let me write down it. When two vectors are multiplied, the result is a scalar quantity. See here, if two vectors are multiplied, the result is a scalar quantity, then the product is called, scalar product. So what is scalar product? If you multiply two vectors, if the result is a scalar quantity, then that kind of product is called as scalar product. Why it is called dot product? Let us check it out. Okay, let me consider two vectors here. Let me consider this is a vector and let me consider this is b vector. Okay, let me take like this. This is a vector and this is b vector. Okay, let me bring a to this side. Okay, this is a vector and let me bring b vector to this side. Let me call it as b vector and let theta be angle between a and b now here, right? So theta is angle between a and b. Okay, we have two vectors and we are multiplying these two vectors, and if the result is a scalar, then that product is called as scalar product. Right? Since the result is a scalar, we write it like this: a dot b. Do you understand? We are multiplying two vectors. If result is scalar, we need to write it as a dot now, right? So what is a dot b? A dot b is equal to modulus of a modulus of b cos theta. Do you remember this formula? What is the formula for a dot b? Modulus of a modulus of b cos theta. What is modulus of a? Modulus of a is nothing but magnitude of a. We have learnt it, right, already, right? If I say modulus of b, it is magnitude of b, right? So modulus of a, modulus of b cos theta, this is a formula for a dot b, right? Shall I write like this? Modulus of a is nothing but a itself, right? Magnitude, right? What is the modulus of b vector? That is b, and what do I get now here? Cos theta, and this is a scalar quantity. If the result is a scalar quantity, then the product is called as a scalar product, or it is also called as dot product, since we write it as dot here, right? So do remember this formula: a dot b is equal to modulus of a modulus of b cos theta. Let us define scalar product. Okay, scalar product of two vectors is defined as, scalar product of two vectors is defined as, okay, whenever in physics, if you want to define a physical quantity, we will be defining it in terms of a mathematical equation. So what is the mathematical equation of A dot B? There is modulus of A, modulus of B, cos theta. Right, let me write. Scalar product of two vectors is defined as, what is it here? Product of. It is defined as the product of magnitude of two vectors. Same. Scalar product of two vectors is defined as the product of magnitude of two vectors and the product of magnitude of two vectors and cosine. Cos theta means what? Cosine of angle between them. Cosine of angle between them. What is theta? Theta is angle between A and B. What is cos theta? That is cosine of angle between them. Right? So define scalar product. Scalar product is defined as product of magnitude of the two vectors and cosine of angle between the two vectors. Right? So cosine of angle between them. So this is define scalar product. Right? So this is what is scalar product. Do you understand? What is scalar product? If you multiply two vectors, the result is a scalar, then it is called as a scalar product. Define vectors, okay, define scalar vectors. Definition, always we write it in terms of mathematical equation. What is mathematical equation? Modulus of A, modulus of B, cos theta. What are they in here? There is a product in here, right? So that is why we write it is defined as the product of magnitude of the two vectors and cosine of angle between them, that is cos theta. Right? Okay, let me take example, then we'll come to know what actually this scalar product is. Okay, let me take the first example. Let me take what are the examples for scalar product. Okay, first example, let me take work equal to. What is the formula for work? Force into displacement. Do remember the formula for work equal to force into displacement. And it is an example for scalar product. How? Let us check it out. Come on, tell me. Force, it is which quantity? It is a vector quantity. Displacement, it is which quantity? It is a vector quantity. I am multiplying vector into vector. What is work now here? It is which quantity? It is a scalar quantity. If you multiply two vectors, if the result is a scalar, then that product is called as a dot product, or it is also called as scalar product. Let me write it symbolically now here, right? Okay, how to write work? The symbol for work is W. Right, so that is equal to, I will not be writing arrow mark in it. Why? Because it is which quantity? Scalar quantity. Scalar quantities are denoted by a letter. Vector quantities are denoted by a letter with an arrow over it here, right? That we have learnt. This is a scalar quantity. Let me write W, and force is a vector quantity. Shall I write like F and a vector over it now here, right? Okay, I will be writing dot. What is displacement? Displacement denoted by small letter S now here, right? So it is also vector. Let me take it as yes. So W is equal to, what does that mean here? F dot S. Why did I keep dot? I kept here dot because the result is which quantity? Scalar quantity. If the result is a scalar quantity, then that product is called as dot product. That is why I will be keeping here dot now, right? F dot S. You know what is the formula for A dot B? Modulus of A, modulus of B, cos theta. Let me write. What is the formula for F dot S? Shall I write like this? The formula for F dot is modulus of F, modulus of S, which theta? Cos theta. Come on, tell me. What is modulus of F? That is F itself, right? Modulus of S vector, that is magnitude. Yes, no here. So what do I get now here? Cos theta. So what is the formula for W is equal to F S cos theta, right? So this is one of the example for a scalar product. Let me take another one example now here, right? Okay. Let me take another example for scalar product. That is power equal to force into velocity. Okay, this is another example for scalar product. Let us check out why it is a scalar product. Force, it is which quantity? It is a vector quantity. Velocity is a vector quantity. What is power? Power is a scalar quantity. Okay, let me write symbolically power. Let me write it as P. Right, since it is scalar quantity, I will not be writing arrow over it here. That is equal to force. Let me write F and an arrow because it is a vector quantity, right? Okay, I will be writing dot. Why? Because the result is a scalar quantity, right? What is that now here? Velocity, that is v. Let me take it as v vector, right? We know what is the formula for a dot b? Modulus of a, modulus of b, cos theta. Okay, shall I write like this? What is f dot v? Modulus of f, modulus of v, which theta? Cos theta, right? What is modulus of f? F now here. What is modulus of v? Magnitude, that is only v now here. That is what we say now here, cos theta. That is p is equal to fv cos theta, and it is a scalar quantity, right? If you multiply two vectors, if the result is a scalar, then that product is called as scalar product. Okay, now let us take some note point about this scalar product now here. Okay, now let us find when is this scalar product maximum or minimum here. Let me take that in terms of note. Okay, in note we know that what is a dot b? What is a dot b? Modulus of a, modulus of b, which theta? Cos theta, right? Modulus of a, modulus of b, cos theta. Okay, now I need to find when dot product is maximum or minimum here, right? One thing what we need to understand here is whenever there is an equation and we need to find is this when it is maximum or minimum, it depends upon maximum or minimum depends upon the trigonometric function in that equation. What is trigonometric function here? Cos theta. It depends upon the value of cos theta. Okay, let us find first when cos theta is maximum and when cos theta is minimum. Then I will be going with the scalar product now. Okay, let me write. Let me take two cases here. Right, in first case, when theta is equal to 0 degree, what happens if theta equal to 0 degree? Theta equal to 0 degree. If theta is equal to 0 degree, that implies cos theta equal to, come on, tell me, what is the value of cos 0? Theta equal to 0 degree, and we need to know what is the value of cos 0. Value of cos 0 is 1, right? You know that value of cos 0 is 1, right? Okay, now let me substitute that in that equation. What do you get? That is a dot b is equal to, what do I get now here? Modulus of a, that is a, modulus of b, that is b. What is cos theta? In place of cos theta, shall I write what we know here? 1. So what do I get now here? ab, right? Here, do remember, a dot b is what we say now here? Maximum. Okay, do you understand? When a dot b is maximum, a dot b is maximum when cos theta is maximum. Do you remember, whenever the equation has a trigonometric function, when trigonometric function is maximum, that quantity will also be maximum here, right? So a dot b is maximum when cos theta is maximum. When cos theta is maximum? When theta equal to 0 degree. Okay, let me write when it is minimum, right? Shall I say like this? When theta is equal to 90 degree. What happens now here? Let us check it out. If theta is equal to 90 degree, what is cos theta equal to? Means cos 90, right? What is cos 90? Cos 90 is 0, right? That is minimum. Okay, what do I get if cos 90 is 0? What do I get now here? A dot b is equal to, what shall I write now here? Modulus of a, that is magnitude of a, that is a, magnitude of b, that is b, cos theta. What is cos theta now here? 0. What do I get now here? 0. Means a dot b is what we say now here? Minimum. Do you understand here, right? So by this we can understand when is a dot b is maximum and minimum. Do you understand? A dot b is maximum when cos theta is maximum. A dot b is minimum when cos theta is minimum, right? In the question paper, the question will be asked like this: when is scalar product maximum? Okay, let me write like this: scalar product is maximum if, okay, scalar product is maximum. When is scalar product maximum? Okay, when is scalar product maximum? When theta equal to 0. What is the meaning of theta equal to 0? Theta means what here? Theta is the angle between A and B. Okay, I think you understand that, right? This is A vector, I took, this is what now here? B vector, this is A and this is B, and what is theta? Theta is angle between A and B. What is the meaning of theta equal to 0? Theta equal to 0 means A and B are parallel to each other. Right? If A and B are parallel to each other, then theta is equal to what now here? 0. The meaning of theta equal to 0 is they are parallel to each other. Okay, let me write like this: scalar product is maximum if two vectors are parallel, if two vectors are parallel to each other, right? If two vectors are parallel to each other, then the dot product is maximum, scalar product is maximum. Okay, let me write. When is scalar product minimum? Scalar product is minimum if, I told you, when is scalar product minimum? Scalar product is minimum when theta equal to 90 degree. What is theta? Angle between A and B. If A is like this, if B is like this, what is the angle between A and B here? 90 degree. Means how the two vectors must be? The two vectors must be perpendicular to each other. Then only it is minimum, right? Scalar product is minimum if, what we say here? Two vectors are, what we say here? Perpendicular to each other. Perpendicular to each other, right? So we need to understand when scalar product is maximum, when scalar product is minimum, right? Scalar product is maximum when theta equal to 0 degree. What is the meaning of theta equal to 0 degree? Two vectors are parallel to each other, right? When the scalar product is minimum if theta is equal to 90 degree. What is the meaning of theta equal to 90 degree? Two vectors are perpendicular to each other, right? You need to know when scalar product is maximum and when scalar product is minimum, right? Okay. Now let me apply this scalar product to the unit vectors. Okay, let me go with the next one. Now let us take unit vectors. You know what is the meaning of unit vector? Unit vectors are the vectors whose magnitude is 1, right? What is the use of unit vectors? Unit vectors are used to specify direction. I think you remember I had mentioned 3 unit vectors, I, J, K, right? If a direction is along the x-axis, so then that unit vector we will be taking it as I cap, right? Cap means unit vector, right? A letter with a cap on it, there is nothing but unit vector, right? A unit vector along y-axis, it is denoted by j cap, right? Unit vector along z-axis, this is z-axis, actually this is the z-axis, right? But I cannot draw here, right? So instead I will be taking like this. This is which axis now here? Z-axis. What is the unit vector along z-axis? That is k cap. Do you remember? I cap, j cap and k cap are unit vectors along x-axis, y-axis and z-axis respectively, right? Do you remember this? I, j, k are the unit vectors along x, y and z. Okay, let me use scalar product on these vectors now here, right? Okay, for example, let me take for unit vectors. For unit vectors, shall I take like this? I dot I. Come on, tell me. Shall I calculate this? What is I dot I? Okay, what is the formula for A dot B? Modulus of A, modulus of B, cos theta, right? What is A I dot I? Modulus of I, modulus of I, which theta? Cos theta. What is theta? Theta is angle between I and I. Did you understand, right? So theta is angle between these two vectors. Come on, tell me, what is modulus of I? Modulus of I is nothing but magnitude of I. What is the magnitude of I? 1. Because I is a unit vector. A vector whose magnitude is 1 is called as a unit vector, right? What is modulus of I? Modulus of I is 1. What is modulus of I? That is 1. Okay, come on, tell me, what is theta? Theta is angle between I and I. What is the angle between I and I? 0 degree. The angle between a vector with itself is 0, right? So angle between I and I, both, let me take now here, that is the angle is 0. Come on, tell me, what is cos 0? Cos 0 is 1. So the answer is I dot I is equal to 1. Okay, let me summarize like this. I dot I, that is equal to j dot j. Shall I say like this also, right? J and j. Angle between j and j is 0 degree. So I dot I, that is also equal to j dot j, that is equal to 1. Then shall I take like this? K dot k, that is equal to 1. Right? Do you remember? The value of I dot I or j dot j or k dot k, that is equal to 1. Right? So do you remember this? Right? Okay. Let me take now let me take two different vectors. Let me take I and j and let us calculate what are the scalar product of those two now here. Okay. Let me write here now here. Right. First of all, let me take what is I dot j. Let me take like this, I dot j. So what is the formula for A dot B? Modulus of A, modulus of B, cos theta. In the similar manner, let me take like this, that is modulus of I, modulus of j, which theta now here? cos theta. What is theta? Theta is the angle between I and j, right? So what is modulus of I? Modulus of I is magnitude, that is 1 here, right? Modulus of j, that is also what we say here, 1, because that is also unit vector, right? So what is theta? Theta is the angle between I and j. Come on, tell me, what is the angle between I and j? The angle between I and j is 90 degree, because one is along x-axis and the one is along y-axis. Let me take, that is cos of 90, right? What is cos 90? Cos 90 is 0. So what is the value of I dot j? I dot j is equal to 0, right? Okay, let me summarize like this. I dot j, that is equal to I dot j. Shall I take like this? J dot k. Okay, do you remember k is in this direction? What is the angle between j and k? Again 90 degree. Again I will be getting the same result now, right? And k dot I, let me take like this, k dot I. So what are the value of this now here? The value is 0. Do you understand? I dot j, that is equal to j dot k, that is equal to k dot I, that is equal to 0, right? Do you remember? Value of I dot I is 1. The value of I dot j is 0, right? If you know the formula, you can calculate it like this now, right? Okay, and here one thing what you need to remember about the scalar product is, if I am calculating what is a dot b, okay, shall I take like this? What is a dot b? A dot b is equal to, do you remember, a dot b is equal to modulus of a, modulus of b, what's in here? Cos theta. If I take what is the b dot a, shall I take like this? B dot a. If I am calculating b dot a, that is modulus of b, modulus of a, what we say here? Cos theta. It is nothing but ab cos theta, it is nothing but ba cos theta, right? Both are nothing but the same. If these two are same, shall I write like this? A dot b is equal to b dot a, right? So shall I say like this? That is dot product. The dot product is, we can say that the dot product is commutative, right? So a star b is equal to b star a, that is commutative property now, right? So do remember, dot product is commutative, means a dot b will be always equal to b dot a, right? Here we have seen that ab cos theta, this is also ab cos theta itself, we will be getting, right? So a dot b is equal to b dot a. By this I can conclude that the dot product is commutative. So this was all about scalar product. So first of all, what is scalar product? What is the formula for scalar product? Definition of a scalar product, examples of a scalar product, when is scalar product maximum, when is scalar product minimum, and let me apply the scalar product for the unit vectors I, j, k, right? You need to know all these things about the scalar product. Now let us move on to the second type of product, that is vector product. Okay, what is vector product? Vector product is also called cross product. It is also called as cross product. What is vector product? If you multiply a vector with a vector, if the result is a vector, then the product is called as vector product. Simple. If you multiply two vectors, if the result is a scalar, then it is called a scalar product. If you multiply two vectors, if the result is a vector, then it is called as a vector product. Right? Okay, let me write. What is vector product? When two vectors are multiplied, when two vectors are multiplied, the result is a vector quantity. See here, when two vectors are multiplied, the result is a vector quantity, then the product is called, vector product. Then the product is called vector product. So this is about what is vector product. When two vectors are multiplied, the result is a vector quantity, then the product is called vector product, right? If you multiply a vector with a vector, if the result is a vector, then it is called as a vector product. Let us take diagrammatically in here, right? I will be using the same process which I had used for scalar product, right? Same steps I will be using here. Just you can understand, you can differentiate the between the scalar and vector products now. Okay, let me take the same. This is a vector. Let me take this is a vector, and let me take this is a b vector. Right? Let me bring it together so that the angle is formed between these two vectors. Okay, let me bring a this side. Okay, I bring a this side. Okay, now let me bring b this side, right? Okay, a I brought this side, b I brought this side. These are equal vectors now here, right? So let me take the angle between A and B is theta, right? Okay, now what is A cross B? Do you remember? If the result is a vector, then it is called as a cross product. We need to write it as cross now here, right? Okay, let me take A cross B, just to differentiate between scalar and vector product. In scalar product, I took as A dot B. Now I am taking it as A cross B, right? So what is A cross B? That is modulus of A, modulus of B, sine theta. Do you remember? There we had cos theta, here we are having sine theta. A cross B is modulus of A, modulus of B, sine theta. Since it is a vector quantity, it must have direction. So to specify direction, which kind of vectors we use? Unit vectors. So let me take it as n cap, right? What is n cap? N cap is the direction of A cross B. Do you remember what is the formula for A cross B? Modulus of A, modulus of B, sine theta n cap. So what is n cap? This is a unit vector which shows the direction of A cross B. Right. So the next question arises here is, where is A cross B? In which direction is A cross B? Here this is A here, if this is B here, A cross B will be perpendicular to the plane containing A and B. Once again, what is the direction of A cross B? Direction of A cross B will be always perpendicular to the plane containing A and B. Okay, this is a plane. Blackboard is a plane containing A and B. Then where is the direction of A cross B? A cross B is in the direction of the duster. Do you remember? This is the direction of A cross B, right? But I cannot draw in this way. That is why let me take like this, right? What is this? This is A cross B. But actually A cross B is not in that direction. A cross B is perpendicular to the board. Since A cross B is perpendicular to the board, I cannot draw a line perpendicular to the board. That is why I am drawing in this way now here, right? So this is A cross B, right? How to denote the direction of A cross B? The direction of A cross B is given by n cap. Let me write, this is the direction of what we say here, n cap, right? So what is the direction of A cross B? It is perpendicular to the plane containing A and B. So what is the formula for A cross B? Modulus of A, modulus of B, sine theta n cap. N cap is the direction of A cross B. Where is the direction of A cross B? Perpendicular to the plane containing A and B. Right. So this is perpendicular to the plane containing A and B. This is the formula. Why did I not write any direction for the scalar product? Because the result was a scalar. What is the meaning of scalar? It does not have direction. That's why I have not written any n caps in the earlier formula, because the result was a scalar. But here the result is a vector. That's why we need to write a direction. So I wrote it as n cap. N cap is in the direction of A cross B. Let me write like this. This can be written. What is the modulus of A? That is A. Modulus of B is B. Which theta? Sine theta. What shall I write now here? N cap. Right. So do remember this formula. What is the formula for A cross B? If the result is a vector quantity, we write it as cross. That is why the name cross product. Right? Okay, let me define it now here, right? What is defined vector product? Vector product, see, vector product is defined as, do you remember in physics, whenever we need to define a physical quantity, we define it mathematically. What is the formula for A cross B? Modulus of A, modulus of B, sine theta n cap. Let me write it now here, right? So vector product is defined as product of, it is defined as product of magnitudes of two vectors, right? Product of magnitudes of two vectors. Modulus is nothing but magnitude. Magnitude of two vectors and sine theta. What is sine here? Magnitude of two vectors and sine of angle between them. Sine of angle between them. Okay, what is theta? Theta is angle between A and B, right? So what is sine theta? That is sine of angle between A and B, right? So once again, vector product is defined as product of magnitude of two vectors, that is A, modulus of A, modulus of B, and sine of angle between them, right? I wrote this and I will be writing about this now. And direction. What is n cap? N cap is about direction, and direction is perpendicular. Where is the direction here? Direction is like this, perpendicular to the plane containing A and B. So this is a board, is a plane which is containing A and B. Where is the direction of A cross B? Perpendicular. What is the direction of n cap? Perpendicular. But I cannot draw perpendicular, that's why I have drawn like this now, right? Okay, let me write about n cap. What is n cap? And direction is perpendicular to the plane containing okay, see here, and direction is perpendicular to the plane containing the vectors. Okay, see here, and direction is perpendicular to the plane containing the vectors, right? This is defined vector product. Question will be asked like this: define vector product, give an example for it. So how to define it? Vector product is defined as product of magnitude of the vectors and sine of angle between them. Direction is perpendicular to the plane containing A and B, perpendicular to the plane containing the vectors. So this is the definition of vector product, this is the formula for vector product, and this is what is vector product. If you multiply two vectors, if the result is a vector, then it is called as a vector product. Let me go on to the examples now here, right? Okay, let us see some examples for vector products. Now, after understanding formula for vector product, let me go with the examples. Right, we need to remember the examples for the vector product. Let me take like this. Examples. First one, that is torque. Torque is a physical quantity. We will be learning about this in the further chapters. First understand what is the meaning of torque now here, right? Torque is equal to position vector. Position vector, let me take, it is position vector into force. Again, this all formula that we will be learning in the further chapters. But we need to remember what is the formula for torque. The formula for torque is equal to position vector into force. Okay, first of all, we need to know what is position vector. It is a vector itself, because we know position vector, there is a vector. It is a vector drawn from a point of reference to the position of the particle, that is called as position vector. We have learnt about this, right? Position vector is a vector. Force, it is a vector. If you multiply the two vectors, torque, it is also what now here? Vector, right? If you multiply two vectors, if the result is a vector, then the product is called as vector product. Let me write symbolically. Torque is denoted by tau. This is called as tau now here, right? Okay, if I write tau, shall I write arrow mark on it? Yes, I need to write, because it is which quantity now here? Vector quantity. Tau is equal to, what is position vector? It is denoted by small letter r. Shall I write arrow mark it? Yes, because it is a vector quantity. Now I will be writing cross. Why did I write cross? Because the result is a vector quantity, right? Force, how to denote force now here? That is F, that is R cross F. What is tau equal to? What is the formula for tau equal to? R cross F. Position vector into force gives torque. Right, this is one of the formula that we will be studying in the further chapters. Okay, what is A cross B? What is the formula for A cross B? Modulus of A, modulus of B, which theta? Sin theta. What shall I take now here? N cap. Right, so modulus of A, modulus of B, sin theta, N cap. Okay, what is modulus of R? R itself. What is modulus of F? That is magnitude, that is F itself. RF sin theta, and what is that now here? N cap. Okay, what is the direction of tau? The direction of tau is perpendicular to the plane containing R and F. Did you understand? Right? If R and F is on the board, then torque will be perpendicular to the board. Right? So torque is a vector quantity whose direction is perpendicular to the plane containing R and F. So this is one of the formula for the vector products. Let me go with the second one. That is angular momentum. Angular momentum. So this is one of the formula. Angular momentum is equal to position vector into linear momentum. So this is one of the formula again that we will be studying here, right? Angular momentum is equal to position vector into linear momentum. Okay, angular momentum, it is written as capital L, right? Shall I write vector? Right, angular momentum, that is equal to position vector, we represent it as R. Since the result is a vector quantity, let me write it as cross product. What is the linear momentum? Linear momentum is small letter p, right? Small letter p is linear momentum, capital letter L is angular momentum, right? Or small letter L you can also write in that way also, right? L is equal to R cross p. Okay, what is the formula for A cross B? Modulus of A, modulus of B, which theta? Sin theta n cap. Right? What is modulus of R? R. What is modulus of P vector? P. RP sin theta, what we say here? N cap. Okay, now what is the direction of angular momentum? The direction of angular momentum is perpendicular to the plane containing R and P, right? If R and P is on the board, then L will be perpendicular to the board here, right? Do you remember? So these are some of the examples of vector products, right? So we have seen the vector product examples are a torque and angular momentum, and we need to remember the formula for that, and this is how we write, right? Okay, now as we have done in scalar product, let us find when vector product is maximum and when vector product is minimum. Let us check it out now, right? Already I told you how to check if something is a maximum or minimum, right? If you have the formula for it, how to check a maximum or minimum, okay? Let me check it out. Let me take that in terms of note points. Okay, first of all, A cross B. Let me take magnitude of A cross B. Right, A cross B is a vector. Let me take magnitude itself. I don't want any direction here, right? Okay, what is magnitude of A cross B? That is modulus of A, modulus of B, which theta? Sin theta, right? I will be not writing n cap. Why I am not writing n cap? Because I took the magnitude, right? Right. If I am not writing this, I must write n cap because it is a vector quantity. I want the magnitude of this because I am calculating when it is maximum minimum, means I want the magnitude itself, right? I want the number. So I will not be writing this n cap, right? Okay, modulus of A cross B, that is magnitude of A cross B is modulus of A, modulus of B, what we say is sin theta. Again, let me take when it is maximum or minimum, right? Shall I say like this? When theta equal to 0. Come on, tell me, what happens if theta equal to 0? What is sin 0 equal to? Sin 0 is 0. Right, you know what is the value of sin 0? Sin 0 is 0. Okay, what happens A cross B? A cross B, right? Modulus of A is A, modulus of B is B. Sin, what we say here? 0, right? Theta is equal to 0. What is sin 0? Right? So this is A, B, and this is 0. What do you get now? 0, right? So 0, we will be getting with 0. Means, shall I say like this? A cross B is maximum or minimum? A cross B is minimum because we got a minimum value, right? 0, right? So once again, let me tell like this. Cross product is minimum when sin theta is minimum. Okay, I already told you, whenever you want to discuss about maximum or minimum, we need to see the trigonometric function. If trigonometric function is maximum, then the quantity is maximum. If trigonometric function is minimum, the quantity is minimum, right? Sin theta is minimum for theta equal to 0 degree. That is why A cross B is minimum. Let us go with the second one, right? When we take theta is equal to 90 degree, right? Come on, tell me, if theta is equal to 90 degree, what is sin theta here? 1, because sin 90 is 1. Okay, shall I apply in here? That is A cross B, right? So let me take magnitude now, right? Modulus of A is A, modulus of B is B. What shall I take now here? Sin 90, sin theta, theta is equal to 90, I am taking, right? This is A, this is B. What is sin 90? 1 now here, right? If sin 90 is 1, what do I get now here? AB, and that is the maximum value, right? So shall I say like this? A cross B is what we say now here? Maximum, right? So I am not considering the direction here. Let me take the modulus now here, right? Okay. So A cross B is minimum when theta equal to 0. A cross B is maximum when theta is equal to 90 degree. The question will be asked like this: when vector product is maximum and when vector product is minimum. Okay. So let me write like this. Vector product is minimum. Okay, let me take now here. Vector product is first, let me write maximum. If vector product is maximum, if, okay, when is vector product maximum? If theta is equal to 90 degree. What is theta? Angle between A and B, right? Shall I like this? Vector product is maximum if two vectors are perpendicular to each other. Perpendicular to each other, right? Perpendicular to each other means we know it is maximum when theta equal to 90 degree. Theta is angle between A and B. If angle between A and B is 90 degree, then vector product is maximum. Okay, now let us find when vector product is minimum. Okay, when is vector product is minimum? when theta is equal to 0 degree. What is when theta equal to 0 degree? This is A vector, this is B vector. Theta equal to 0 degree means they must be parallel to each other, right? Okay, vector product is minimum if, what we say here, two vectors are parallel to each other, right? It is just opposite of scalar product, right? So vector product is maximum when they are perpendicular to each other. Vector product is minimum when they are parallel to each other, right? Once again, vector product is maximum or minimum depends upon the trigonometric function, right? Sin theta is minimum when theta equal to 0. Sin theta is maximum when theta equal to 90 degree, right? Okay, this is how we came to know that when vector product is maximum and when vector product is minimum. Now let us use this vector product in terms of unit vectors, right? Okay, the same thing as I had done for scalar product, here also I will be doing it for vector products. Let me take unit vectors. You know, unit vectors are the vectors whose magnitude is 1 and they are used to specify the directions, right? So once again, if a vector is along x-axis, what is the unit vector? I cap. If the vector is along y-axis, what is unit vector? J cap. Right? If the vector is along z-axis, means it is in this way, I cannot draw like this, that's why I am writing like this. So what is the unit vector along z-axis? That is k, right? Okay, now let us find the first one, right? For unit vectors, let me take the cross product for unit vectors. Okay, first of all, let me write like this: I cross I. Okay, do you remember? Earlier I took I dot I. Now I am taking I cross I. What is the formula for A cross B? Modulus of A, modulus of B, sin theta n cap. Right? Okay. What is A cross A? I cross I? That is modulus of I. Modulus of I. Which theta? Sin theta n cap. Right? Okay. That is equal to. What is modulus of I mean? 1, because it is a unit vector. What is the magnitude of a unit vector? I is a unit vector, right? So that is why I written cap on it. If a letter with a cap, it gives unit vector and its magnitude is 1, right? Modulus of I, what is modulus of I? 1. Come on, tell me now here. Sin theta, theta is angle between I and I. What is angle between I and I? The angle between I and I is 0, right? I, the vector with the same vector, the angle is 0. What is it here? N cap. So what is the value of sin 0? Sin 0 is 0, right? So whole term will be equal to 0. Okay, shall I write like this? That is I cross I, that is equal to J cross J, because again if the angle between J and J is again 0 no here, that is why J cross J is also 0, that is equal to K cross K, that is equal to 0, right? So do remember what is the value of, the question will be asked like this: what is the value of I cross I? Do remember the value of I cross I is 0. What is the value of J cross J? 0. K cross K? 0. Right? So do remember, if you know the formula, you can write it directly now here, right? Okay, now let me find what is the cross product of two different vectors now here, right? Let me take like this. Okay, let me take I and J now here. Okay, first of all, I cross J, right? Again, what is the formula for A cross B? Modulus of A, modulus of B, sin theta n cap. Okay, let me take I cross J. That is what now? Modulus of I, modulus of J. Which theta? Sin theta. What is that now here? N cap. That is the formula, right? So modulus of I, modulus of J, sin theta n cap. Come on, tell me, what is modulus of I? That is 1. That is unit vector, and magnitude of unit vector is 1. Right? So what is the modulus of J? That is also 1. That is the unit vector whose magnitude is 1 again. That is sin theta. Theta is angle between I and J. Right? What is the angle between I and J? 90 degree. Right? So that is sin 90. What shall I take now here? N cap. Right? Okay. Come on, tell me. This is 1 and this is 1. What is sin 90? Sin 90 is also 1. Right? So this is which vector now here? N cap. Come on, tell me, what is the direction of n cap? N cap is in the direction perpendicular to the plane containing I and J. Come on, tell me, if this is I and this is J, where is perpendicular to the plane containing I and J? It is nothing but what? K cap. Okay, instead of this, shall I write what now here? K cap, right? So what is K cap? K cap is a vector perpendicular to the plane containing I and j? Of course it is right? Zx is perpendicular to the plane containing x and y axis. So what is the value of I cross j? The value is k cap now here, right? Shall I write like this? I cross j. Okay, that is equal to what shall I write now here? That is equal to k cap, right? I cross j is equal to k cap. Okay, again if I am calculating like this, j cross k, that is equal to, remember whenever I write about the cross, I k, what is remaining now here? Sorry, j k, what is remaining? I. Let me take it as I cap. But here we need to follow one rule now here, right? So this is the rule. If I am taking, this is I, and if I am taking, this is j, and there is circle like this, right? Let me take like this. This should be in order. I, j, k should be in order. If I am taking I cross j, it should be k, right? I cross j, it should be k. K cross I, it should be j, right? So let me take now here, right? So what shall I take now here? I dot j is equal to k. Let me take like this. K cross, what is that now here? I. K cross I. If it is k cross I, what do you get now here? J, right? It is like that, right? Then what is I cross j now here, right? If I am taking I cross j is equal to k, k cross I is equal to j now here, right? Again, if I am taking like this now here, j cross k, what is j cross k? That is equal to what we say now here? I, right? This is circular if it is like this. What will happen if it is reverse of this, right? Okay, just you need to understand here, right? Let me take a reverse of this. Instead of taking I cross j, if I take j cross I, just to understand here, j cross I, remember I cross j, I am taking j cross I. Where is j cross I? I am taking in the reverse of this way, right? I am not taking in the order. I, j, k are in order. If I take a reverse of this, the result will be a negative vector. This is a thing what you need to understand, right? Everything we cannot solve now. You need to remember in this way, right? I, j, k. What is I cross j? K. J cross k, I. If it is in the order, you take it as a positive vector. If it is in the reverse order, take it as a negative vector of that, right? Okay, let me take j cross I. What is j? J cross I. I am going reverse. Then what is the answer here? Minus k cap. Do you understand? See here, I dot j, it is in the order, I got k. This is j cross I, it is not in the order, let me take it as minus k. Okay, let me take like this, reverse of this. K cross j, what do I get? Where is k? See, k cross j, I am going reverse. Then I need to take a negative vector. That is what I have. Minus I vector. Right? Okay. Let me take a reverse of this. That is I cross k. Okay. What is I cross k? Let me take like this. I cross, I am going reverse. I should take a negative vector. That is minus j vector. Do you remember? Simple. What is I cross I? That is equal to 0. J cross j, 0. K cross k, 0. Right? If I want to calculate what is I cross j, right, I need to remember this circular form, right? If it is in the order, take the third vector, right, in positive, right? If it is in the opposite order, take the third vector, but it is in negative. Let me take like this, right? And one thing what you need to remember here is A cross B is equal to minus of B cross A. Do you remember this, right? Right? A cross B, if I am taking B cross A, they are opposite now, right? Opposite direction. A cross B is equal to minus of B cross A. Let me take like this. That is cross product. Cross product is not commutative, right? We had concluded the dot product as dot product is commutative, but cross product is not commutative because A cross B is not equal to B cross A. A cross B is equal to minus of B cross A. Did you understand? That is why we got a minus signs here, right? So do remember A cross B is equal to minus of B cross A, and the cross product is not commutative, right? Just I applied the vector product for the unit vectors, right? You need to remember this, and you need to remember that circular also, right? It's very simple to remember it now here, right? Okay, just you remember this ij case and you'll come to know, right? Once again, let me give you last example and close this session now here, right? I, j, k, it is in the order. right? So what is the answer for j cross k? J cross k, it is in the order itself. So what is the answer here? I, the third one, right? Okay, what is the formula for j cross I? Okay, j cross I, I am going reverse, means this should be negative vector. So what do you get now? Minus k cap, right? So this is how to find a short way to find what are the vector products of the unit vectors, right? Unit vectors are the vectors whose magnitude is 1 and they are used to specify the directions. So this was all about the scalar product and vector product, right? You need to know what is the meaning of vector product and what is the formula for it, define vector product, examples for the vector products, and when vector product is maximum, when vector product is minimum, and we need to apply the vector products for the unit vectors that we have done here, right? So these two are the product of two vectors, that is the multiplication of the two vectors, right? So this completes multiplication of two vectors. Thank you.